Okay, today we're going to finish off Investigation 8. We're going to talk about the rock cycle, and we'll do a little review of the igneous and metamorphic rocks. Here are some of the questions that we went over as a review. How do igneous rocks form? Okay, heat inside the earth melts down the rocks. The melted rocks can cool and form igneous rocks. Again, there are two main types of igneous rocks. There are the intrusive igneous rocks, such as granite, which form inside the earth, and that's why they're intrusive. And then there are extrusive igneous rocks, which form at the earth's exterior or outside on the earth's crust. And those would be ones like obsidian, pumice, basalt, just to name a few. How do metamorphic rocks form? When tectonic plates interact, high heat and immense pressure can change the rocks into a new form. We looked at the different types of igneous rocks: schist, gneiss, marble, quartz-style, and slate were the 5 that we looked at in class. We looked at the lab on how crystals form, and basically we wanted to know that the minerals inside the rocks form in a crystal shape. Okay, it's not that they're actually forming crystals like diamonds, but that the minerals form in a geometric shape of a crystal. So the different sizes that they form in depend on where the rocks cooled. If they were intrusive, they're going to have larger crystals. And if they are extrusive igneous rocks, they're going to have smaller crystals, if any crystals at all. What are some of the ways that mountains form? Mountains form from the interactions between tectonic plates at their boundaries. It deforms the plates, producing landforms on Earth's surface. Mountains form as a result of those tectonic plate interactions. Think of it as a crumpled up hood on a car. Okay, as those two plates or two cars collide, the crumple zone or the hood of the car gets deformed and kind of gets folded up, and that's what we call fold mountains, or that's the way most mountain ranges on Earth are formed. I also have a little video that goes over metamorphic rocks and talks a little bit about mountains forming. So I'm going to play that now.
It takes great forces to raise rock out of the sea, bend the layers and tilt them, and make them into mountaintops. These same geologic forces also work deep in the crust. There, great heat and pressure break and realign the atoms of the mineral crystals. This creates a new structure, a new mineral.
The result is a rock like this. It may once have been an igneous or a sedimentary rock. And then, deep within the earth and at great temperatures, pressures were exerted on the rock like this. The bands that we see here are the new minerals that formed under that great heat and pressure. We can see that this rock has alternating bands of light minerals and dark-colored minerals. We can see that the bands in this rock are not nearly as uniform in color or thickness as the layers we saw in the sedimentary rocks. This rock is called gneiss. It's part of a larger class of rocks called the metamorphic rocks. Metamorphic means changed form, and we can see why. Hundreds of millions of years ago, it may have been like the granite we visited earlier, or like the layered sandstone. But it was changed under great heat and pressure into a very different kind of rock.
Okay, as we come back, talking about metamorphic rocks, one of the metamorphic rocks that I like to focus on in class is marble. We looked at marble in class, and we've seen that it reacted with our hydrochloric acid. And if we remember back from earlier labs, hydrochloric acid reacted with limestone because it has calcite in it. Since marble comes from limestone, or that's its parent rock, we can conclude that metamorphic rocks will often carry along some of the properties of the rocks that they form from. And marble is one main example of that I would make sure to know for tomorrow. Okay, one of the last things here is the rock cycle. And the rock cycle very simply is the transformation that changes one type of rock to another type of rock. We also gave out this diagram in class to go over the rock cycle. Okay, with this diagram we can see at the top here that igneous rocks, okay, can change into sedimentary rocks through weathering and erosion, or igneous rocks can change into metamorphic rocks through heat and pressure. Metamorphic rocks can be changed into igneous rocks if they melt back down, or metamorphic rocks if they make their way up to the surface of the earth. They can weather and erode into sedimentary rocks. Also, we look at sedimentary rocks, and they can change into igneous rocks if they melt back down, or sedimentary rocks buried deep within the earth can change through heat and pressure back into metamorphic rocks. We did talk a little bit more, and there are some exceptions to the rock cycle that we talked about, where igneous rocks can stay as igneous rocks and remelt back down, or sedimentary rocks would be able to erode and weather again and become a different type of sedimentary rock. But for the test, we're going to keep it pretty simple, and we're going to look at this diagram. And for the test, we're probably going to just be making some of these boxes blank, and we're going to have to then just fill in some of the blank boxes. Some of the last things for the test that I would make sure to know for tomorrow, what the igneous rocks that we looked at in class were. There were 6 of them: granite, basalt, obsidian, pumice, scora, or scoria, and tuff. And the metamorphic rocks were schist, gneiss, or gneiss, marble, quartztile, and slate. If you have any other questions, make sure to stop by sometime in homeroom or sometime before your test tomorrow. Otherwise, have a good night.